gaan oor hoe kan ons reaksies vinniger laat plaasvind. This whole chapter is how can we make reactions take place faster. En I link met hom, maar as dit dieselfde is. Ja. Alright, so hierdie hele hoofstuk soos ek sê, this whole chapter is how can we make reactions take place faster, vinniger. Hoekom? Want time is money. Ons wil hê dit moet so gaan. Okay. Now it says there, not all chemical reactions react at the same speed, not the same speed or the same rate. Okay, for example, when something rusts, it takes very long to take place. As iets roes, vat dit baie lank. Sodium reacts very quickly with water, blah, 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 blah. So not all reactions happen at the same time. And therefore, we take an average rate. Dus wat 'n gemiddelde tempo. Okay? Then a bit of theory before we go on. What is a homogeneous reaction? A homogene. We know homo means the same, dieselfde. So a homogeneous reaction is where the reactants and the products are in the same phase. Waar hulle in dieselfde fase is. Okay? En fase, phase, is like solid, liquid or gas. Dis wat ons bedoel in dieselfde fase, in the same phase, solid, liquid or gas. And a heterogeneous reaction, die heterogene reaksie, is where the reactants and or the products are not in the same phase, obviously. Okay. How do we calculate the rate of a chemical reaction? Hoe bepaal ons die tempo? Okay. The definition there binne. Iemand klop. Hallo? Merk jy nog af? The definition there is the change in concentration. Hallo, hierso fokus. Die verandering in konsentrasie van reaktante of reagense of produkte per eenheid tyd. Okay. Now, you can see here on the right hand side, I also wrote down or mass, or volume, or mole. Okay? Want baie keer, sometimes, jy kan hier so ook sit. Okay? Want baie keer, sometimes, we won't be given the concentration. Ons gaan nie die konsentrasie gegee word nie. We will be given the mass, or we will be given the volume, or we will be given the whatever. Okay? So, when they ask for the definition, wanneer hulle vra vir die definisie, then you can say the change in concentration, doesn't matter what they ask, of jy kan dit verander dat spesifiek op die vraag van toepassing is. If you see in the question, they speak about mass, then you can say it's a change in mass of reactants or products. Okay? Then, per unit time, per eenheidstyd. Sometimes we're going to work in seconds, want die reaksie gebeur net so. Sometimes it will be in minutes. Sometimes it will be in hours. So that is why they say per unit time, per eenheidstyd, want baie keer gaan sekondes, minute, ure, wat ook al wees. Okay. And then lastly, is reactants or products, en ons gaan nou daarna kyk. We're going to look at why they say reactants or products in a moment. Okay, maar daar is 'n definisie, and they like to ask this definition. Hulle hou daarvan om die definisie te dra. Then you must be able to calculate the rate. Jy moet die tempo gaan bepaal. And rate, tempo beteken, as jy dit hoor, dink jy nou weer wat? Yes, if you hear the word rate of tempo, dink jy gedeel deur tyd. So what must you divide by time? Either the concentration, or the mass, or the volume, or the mole, or the whatever. Okay? Goed, so hier aan die regterkant, on the right hand side, you can see there's two equations, twee vergelykings. And they look exactly the same. Hulle lyk presies dieselfde. Except for, behalwe, die een het 'n minus in, en die ander het nie 'n minus in nie. Okay. The reason why they are like that, die rede hoekom hulle so lyk, is wanneer jy van die reaktante gebruik maak. Nee? Reaktante is die goed waarmee jy begin. The thing that you start with. When I make muffins, okay, when I use the flour, as ek meel gebruik, daar begin ek met baie meel en ek eindig met min meel. I start with a lot of flour and I end with little. And how do you calculate the change in, die verandering in? Change in, how do you calculate that? final minus initial, né? So as ek met min eindig, if I end with very little and I start with a lot, dan gaan dit wees a small number minus a big number. You'll get a negative answer. Okay? And that is why you have a negative in the equation, so that your answer is never a negative. Okay, right. Now, this equation is not on your data sheet. Okay, if I remember correctly, I don't think it's on your data sheet. Okay, so not on data sheet. Okay, so jy kan hierdie vergelyking gaan verander. You can change this equation and we're going to practice it today. I always just write down this one. Ek skryf altyd net die positiewe een hier. And then if I see my answer is a negative, I go back to the equation and I put in a negative. Okay, so dit is nie die einde van die wêreld, so at the end of the world. Just know that your answer, your antwoord is nooit negatief. Your answer can never be negative here. Okay, and then the last thing with this calculation, die berekening, is your eenheid, your unit. Okay, that unit is not fixed. It is nie vas nie, not fixed. Okay, what do I mean with that? Dit hang af wat hulle vir jou gee. Are you going to divide concentration by seconds? Of gaan jy massa, die verandering in massa oor die verandering in minute? Then it's going to be grams per minutes. Okay, so it depends what they give you. Dit hang af waaraan jy werk. So it's not fixed, that unit. Goed, dan het ek onder net vir jou gesê, onthou, hy moet altyd positief, jou antwoord is altyd positief. Your answer must always be positive. Okay. Now, how do we measure the rate? Hoe meet ons die tempo van 'n reaksie? And we're going to do a few experiments today, hopefully. Okay, we are going to determine the rate, the tempo. You determine by getting the amount of reactants that is used, die hoeveelheid reaktante wat gebruik word, or the products that are formed. Okay, so you measure the rate, you measure the tempo, you have to kyk of hoeveel reactante word gebruik, how much of the reactants is used, or how much of the product is formed, and that is for a certain time interval that must be constant. So jy sê goed, ons gaan elke 10 secondes dit meet. Every 10 seconds we measure one of the two. Okay, so how do you measure it? The first way that you can do it is by measuring the ions, die ione. Okay, so gaan lees en dan verduidelik. Dit sê, as ione gebruik of gevorm word tydens 'n reaksie, dan dien die elektriese geleidingsvermoë as 'n aanduiding van die konsentrasie op verskillende tye. Okay? So an ion, 'n ion, is it's something like let's say sodium ion, chlorine ion, something with a positive or a negative. And something with a positive or negative can conduct electricity. Dit kan elektrisiteit gelei. Ions, ione, kan elektrisiteit gelei. So if your reaction produces ions, jou reaksie ione produseer, okay, then it will conduct electricity better and better and better and better. Nee? Ja. So, as jou reaksie ione produseer, dan gaan hy elektrisiteit beter gelei en beter gelei en beter gelei. So then you can put in a light bulb, or you can put in an ammeter, or you can put in your voltmeter or whatever, and see how the current increases per unit time. Okay, so dis een manier om dit te doen. Dan die volgende manier is om te kyk na kleur. You can look at color. The change in color. The change in color can be measured by a spectro... is daai woord? spectrophotometer. Donna? And that gives you an indication of the concentration. Okay, think of concentration like if you have your, I don't know how much of you like to bake. Okay, kom ons kan almal cool drink. Everyone has made cool drink in their life with Oros or whatever you use, né? If you have very little Oros in with water, then sit so deurskynend. And then some people do half. Nee, half Oros, half water. As is so donker. Okay? So the clear, the color gives you an indication of the concentration, how concentrated it is. Okay, so daar is die idee daar. The next one is one that we use a lot, is a precipitation, a neerslag, precipitation. And the precipitation is the ratio between, deursigtigheid in Engels, between the visibility.
Transparency.
Dis wat ek genoem. Daarna. Deursigtigheid en die konsentrasie van die neerslag kan bepaal word. Okay. And we are going to look at a reaction today that makes a precipitation. En neerslag is 'n onoplosbare sout. It's a Ja, maar wat is dit? Ja, ek is spelling. Ja. Insoluble salt. 'n Onoplosbare sout. Okay. So it forms, we use precipitates a lot as paint. Hallo, dankie. Ons gebruik neerslag baie keer as 'n verf, want jy wil nie hê 'n verf moet oplos as dit reën nie, né? As jy mure verf wil nie dit oplos nie. Ja. The ratio between solubility and concentration. Not solubility, transparency. And concentration. Siamo is in the notes. Oh, okay, Shaf. Okay, and then, ja. Siamo.
Ja, en
Katlego.
dis 'n kat.
Ja.
En tapelo.
Tapellos nie. Nog nie. Kyk.
En dis die pangie.
Ja, ek het al gesien, ja.
Okay, so dis net tapelo en chalet.
Ja.
Want die is die
Chichi. Alright. Dankie. Dankie. Hallo. Nestel. Dan die laaste een wat ons baie gebruik is gasse. Is gases. Okay, so the last two we use a lot in science class. So gases can be measured in two ways. Okay, kan twee maniere bepaal word. Of die massa van die gas kan bepaal word. The mass of the gas can be determined. How do you measure the mass of a gas? By determining the loss of mass of the reaction mixture. Okay? Or the volume of the gas can be collected as shown below, and shown below is called the downward displacement of what, you remember it from grade 9? Die afwaartse verplasing van water. The downward displacement of water, die afwaartse verplasing van water. So what you should have done in grade 9 is you take zinc in soap sea, hydrochloric acid, and it starts to bubble. And that bubble is a hydrogen gas that is given off. Waterstofgas wat afgegee word. Okay? Goed, hierdie ons praat van 'n Erlenmeyer fles. We call this an Erlenmeyer flask. Okay? Dan is hier 'n stopper, 'n klipprop, and there's a delivery tube. It's a glass tube that is bent and it goes down and down. Here we have a water bath, a waterbad. met water in, water bottle. And then you have a test tube that you fill with water. So you have a proefbuis wat jy vol water maak en dan sit jy hom so onderste bo. And then ek gaan nou weer wees. And then the delivery tube, die afleibuis in Afrikaans, delivery tube is 'n afleibuis. Okay, and it goes up in the air, and the bubbles, die gasborrels gaan hier in. The gas bubbles goes up in here, and it pushes the water down, and you can collect the gas like this. And the gas is given off is hydrogen gas, waterstofgas. Hoe toets jy vir waterstof? Steek jou hand op vir 'n sweetie. Hoe toets jy vir waterstofgas?
Jy gaan ons hy vuurtjie daarbo. Soos jy gaan hom daarbo hou en dan as hy begin brand.
Nee, verkeerd. Not enough. Yes. So die vuurhoutjie of die vlammetjie wat jy insit, the burning splint that you put in will explode. It will make a pop sound. Pop, like that. Okay. We can maybe collect it today and then we'll test it. Ja. Ja, hierdie een is nie. Alright, hallo graad 12. Sst. Jy is nog nie eers 'n uur hier nie. Dis nou eers 'n halfuur wat ons begin. So shush. Okay. Then. Ek is dood ernstig. Ek gaan julle uitstuur. Shh. Ek gaan nie vir 4 ure kan sê bly stil. Okay. The next one, the collusion theory, die botsingsteorie. Okay. Now this definition, they don't ask that often. Hulle vra nie die definisie so baie nie. They ask more the application of this definition, die toepassing van hierdie definisie. Okay, die definisie sê die botsingsteorie is 'n model wat die reaksietempo verduidelik, so it explains the rate of the reaction. And how it explains it, that the particles that collide with one another, die deeltjies wat met mekaar bots, moet 'n sekere minimum energie hê. Must have a certain minimum energy to form products. Okay. So what they mean with that, for a reaction to be effective, that word effective is important. Vir 'n reaksie of 'n botsing om effektief te wees, moet die volgende geld. En hierdie twee goed is super belangrik. You can say I highlighted them and I bolded them. First of all, the particles must have sufficient kinetic energy. Nie net kinetiese energie nie, sufficient, genoegsame kinetiese energie. And what does enough kinetic energy means? It means greater or equal to the activation energy. Groter of gelyk aan die aktiveringsenergie. Okay, so what we mean by that is as ons kyk, if we look at, I've explained this last year to you as well. So as jy oggend opstaan, dan maak my man my wakker met koffie. Nee? And then before I walk out of my home, I need to have my takeaway flask in my hand. Nee? Onder jy ek het dit laas jaar gesê? Goed? And if you give me Ricoffee, Nescafe, Jacobs, it's not going to be sufficient. I know, I am a coffee snob. I need my coffee machine coffee. Okay, nie 'n espresso, dis 'n machine. Dis 'n filter machine. Ja, maar jy kraai my of kraai nie bone vars.
Ja, dis daai wat is
Anyway, right, so I'm like that, yes, so when you stick for coffee nie. Dankie. So, it must be sufficient kinetic energy. You are different, you're not a snob like me, so you will be happy with your Nescafe or your okay? Good. So it will differ for each reaction. Dit sal verskillend wees vir elke reaksie. Maar nommer 1, hy moet genoegsame kinetiese energie, sufficient kinetic energy. Secondly, tweede ding, it must have the correct orientation. Hy moet die regte oriëntasie. Dit help nie, it doesn't have to help if I have an eye on my head and ek sê, hey, what's up? En dan sê dit gaan jy. Okay? So it doesn't help that I want to make this reaction happen, but I don't have the correct orientation. She's not interested in alleen vriend. Goed, so dit is belangrik. The second thing is important. You can try to make the reaction happen, but if it doesn't have the correct orientation, it will not. Okay, so dis die tweede ding, is hy moet die regte oriëntasie hê. Okay. So, the first thing there is the sufficient kinetic energy. Genoegsame kinetiese energie. Ek gaan lees en dan verduidelik. Dit sê, vir 'n reaksie om plaas te vind, moet die botsende molekule 'n totalende, so die botsende molekule, the molecule that will collide, the total kinetic energy that is equal to or greater than the activation energy. So die kinetiese energie, I'm going to write here the kinetic energy must be greater or equal to the activation energy for the reaction. Okay, then I did say the activation energy varies from reaction to reaction. Okay, like I need my machine coffee, you are happy with your whatever. Dan, baie belangrik. Molecules do not have the same kinetic energy on the same time or at the same time. Okay, so as ek wat is hier bedoel is when I look at you in this class, some of you are morning people, jy's wakker, jy's hier, jy's teenoorig, party van julle gaan eers 12 uur wakker word, nee? Some of you are warm and some of you are getting cold. So as you are sitting here, I can't say the energy you guys have, you all have 1,000 joules, okay? I can say some is 200, some is 2,000, and I can get the average kinetic energy. So wanneer ons iets se temperatuur weet, when we measure something's temperature, we take the average temperature. Okay. Now, because they don't all have the same kinetic energy at the same time, we can draw a Maxwell-Boltzmann curve. Okay, jy moet daai naam ken, hy's onder streep. We can draw a Maxwell-Boltzmann curve. Okay, goed. This is what the curve looks like. Okay, so kom ek verduidelik gou vinnig. Jy moet hom kan teken en jy moet hom kan interpreteer. You must be able to draw it and interpret it. So you must understand it. On the y-axis, you have the number of particles. Jy die hoeveelheid deeltjies. So dit is, sê net maar die hoeveelheid kinders in die skool. The number of learners in the school. Okay? Is given on the y-axis. On the x-axis is the energy, die energie van die deeltjies. Okay? And the energy here is the kinetic energy of the particles. Die kinetiese energie van die deeltjies. Okay. Now, as ons na die skool kyk in geel, if we look at the school in general, there's about 600 learners in our school. Of that 600, how many do you think will pass science if they are all forced to take science? Kom ons maak net in matriek. In matriek kom ons sê daar's 100 kinders in matriek. There's 100 learners in matriek. If they are all forced to take science, how many will pass? 5%. Hopefully those that are sitting here today. Julle is so 35. You're about 35. Ja. Almal gaan julle ook. Okay, goed, so. What this graph represents is all the learners, alle leerders, but a big chunk of them will not, if we take this, the energy as percentage. Okay, this energy is percentage. The most of them, their percentage will be too small. Okay, as hulle moet wetenskap neem, gaan hulle 20% kry. Okay? Good. And then somewhere is the cut-off line. Kom ons sê die cut-off line vir wetenskap is 50%. Okay? So you need to get 50% to pass. Then, dankie. Then some of you won't make it. But then, daar's die cut-off line. And a klein bietjie, a small amount, will have a percentage high enough. Okay, shall I make mine? Okay, now let's get back to science. It is the energy. This cut-off line is the activation energy. What is the activation energy again? The definition. Steek jou hand op. Vir 'n sweetie. Ja? Okay. Okay, is jy besig om te skryf? Are you busy writing down? The minimum, asseblief julle. The minimum, in English, the minimum energy needed for a reaction to take place. The minimum energy needed for a reaction to take place. Okay, so in your head, you can think of the cut-off. Okay. So daai activeringsenergie, that is a cutoff. If you have energy lower than that, then these particles will not react. Hierdie deeltjies gaan nie reageer. Only the particles that have sufficient kinetic energy, greater or equal to the activation energy, they will react. Okay. So the Maxwell-Boltzmann curve shows you how many particles does not have sufficient enough genoegsame kinetic energy, and how many does have sufficient kinetic energy. Okay, right. So dit is wat op bo verduidelik word. This is the number of particles that don't have enough energy. And this is the number of particles that have high enough energy. Ek het skool gegaan so wat hulle so skool gegee. En ek het so skool gegee vir 5 jaar. No. Alright. En hermanus. Alright, then the next one is the correct orientation. Die regte oriëntasie. The correct orientation, I'm going to zoom in there at the bottom again. As you can see here, this reaction that we have, I think this particle represented carbon dioxide. No, it's not carbon monoxide, it's methane. Nee, ethene. En hierdie ene dink ek was soutsuur. Okay. So dis wat deur daai molekules verteenwoordig word, just if you're interested. If you can see, I'm going to start on the right hand side. Ek gaan aan die regterkant begin. Sien jy? As jy kyk na soutsuur, sorry, ek vergeet om dit te sê. Chlorine is the bigger molecule, right? So this is chlorine, this is hydrogen. Hier is waterstof, koolstof, waterstof. If we look at the valencies, hulle valencies, hydrogen is positive, chlorine is negative. Positive. And koolstof, carbon, can be either +4 or -4. So if carbon is bonded to hydrogen, that is positive, then carbon will be negative. Okay, goed. So that's the same for all the molecules. Ek wys hom nou net vir een, want dit is dieselfde vir hulle almal. So if this comes in here and it wants to collide, I will know hierdie bindings break. It wants to break those bonds to form a new something. Will positive and positive bond? No. Okay, so this will hierdie, die gaan daar, it's not going to work because positive and positive will not react with one another. If you look here, this is negative and negative, will not work. And also dodge binding break. We want to break that double bond there. So it's coming in from the wrong side. Gaan nie werk. Orientation is incorrect. If you look at this one here, it's coming incorrect. Want ons wil daai binding breek. But this is negative, that is negative. Gaan nie gebeur nie. So it must have the correct orientation. Okay, so the feit that a reaction plays, in fact that the reaction takes place, is sort of like a miracle. Correct orientation and sufficient kinetic energy. It's almost like, and I know this is a silly example, but it's almost like someone getting pregnant. Nee? It's a miracle. Okay? Those that take life sciences knows daar's so baie goeders wat kan verkeerd gaan. Dit is regtig 'n miracle if you get pregnant and if the baby survives the pregnancy. Okay. All right. Goed. Now we're going to look at Dankie. Hallo. Jy stil. Ons gaan kyk na die faktore. We're going to look at the factors. Hallo. Na die faktore wat 'n reaksie beïnvloed. Okay. There is Alright, there's 5 things that influences the rate of a reaction. 5 goeters. Okay? The first thing there is the aard van die reagense. Wat is die aard in Engels? The nature, thank you. Then the surface area, die oppervlakte area. The guy mentioned all of this in the video. Then the concentration, die konsentrasie. Dan op die volgende bladsy staan die temperatuur, the temperature, and then a catalyst. Katalysator. Okay, so ons gaan al 5 goeders noem and you must know these 5 things and you must know how they affected en dan moet jy nog vrae daaroor kan beantwoord ook. Okay. The first one is the nature, die aard van die reagerende stowwe. Okay. I'm going to read and then explain. It says there, die tempo van 'n reaksie hang van die aard van die stowwe wat deelneem. Reaksies wat soortgelyk lyk, it looks similar, kan onder dieselfde omstandighede, if they have the same circumstances, they can have different rates. So, the same circumstances, dieselfde omstandighede, kan hulle verskillende tempos hê. They can have different rates because of the nature of the reactants, die aard van die reaktante. Okay? It's like I can teach the same lesson to all of you, same circumstances, same questions, same notes, same everything. Julle gaan nie almal dieselfde persentasie kry. Okay? It depends, and let's say you all study the same number of hours, en. Alles is dieselfde. But some of you, your capacity for science is not as high as others. Okay? It is heel normaal, you can see my language capacity is hier so op die vloer. Nee? Goed, so dit kom net natuurlik, it just comes naturally to you, and others it does. The same thing with the substances that we work with, stowwe waarmee ons werk. Dit om nou nie uitgehaal agter die. Here we have acidic acid, asynsuur, suiwer, asynsuur, and here we have hydrochloric acid, pure hydrochloric acid. Albei is sure, both is acid, but acidic acid is a very weak acid and hydrochloric acid is a strong acid. Okay? Ons kan hulle op dieselfde temperatuur hê, dieselfde konsentrasie, alles, but hydrochloric acid will work a lot faster than acidic acid. Why? Because it's a stronger acid. And we're going to get to acids and bases a bit later. Maar hy is 'n sterker suur, so hy reageer vinnig. Okay. So the nature of the substances. Now hierso is where you must know your grade 10 work very well. Okay? Jy moet nou 'n lyste van goed wat ons gegee het, 'n list of substances. En dan het ek so snippets gegee soos this is a strong acid, this is a weak acid, this is ED, this is ED. Yes. So that you need to know very well. Okay. Few examples here, 'n paar voorbeelde hier. If we look at iron versus sodium in air or in anything, and we see at how it rusts, hoe dit roes. Watter een dink jy, which one do you think will, put up your hand, will rust faster, will react faster? Shazal? Nee, is verkeerd. Obviously, is die ander een. Okay. So, the one that reacts faster is sodium, natrium. Okay. Yster gaan lank vat om te roes. Iron will take very long to rust. Sodium reacts like this. We keep, so yster los ek hier agter net oop. I just leave it open. I don't do anything with it. Sodium we keep in an airtight container inside oil. Okay. In olie. Want as hy in lug, if it comes in contact with air, then it starts to react. Okay? So natrium gaan die vinnigste wees. And how are you going to remember this? If you look at sodium, where does sodium sit on the periodic table? Group 1. Group 1 is called, hy is in Group 1 is in group 1. Group 1 are called not only alkali metals, dit word genoem reactive alkali metals. Okay. Groep 1 is super reactief. It's very reactive. Reactive alkali metals.
Juffrou, is dit omdat hulle
Okay. Then if we look at calcium teenoor natrium, weer eens, watter een gaan vinniger reageer? Sodium. Because it's in group 1. Where is calcium? Calcium is in group 2. Group 2 is also called alkali metals, but it's called not reactive. It's called alkali earth metals. Alkali aardmetale. Okay? Then if we look at hydrochloric acid versus sulfuric acid. Soutsuur teenoor swaalsuur. Both are strong acids, maar swaalsuur, sulfuric acid there, you can see it can give away 2 hydrogens. Okay? So hy gaan vinniger reageer, it's going to be faster because it gives 2 hydrogens. Okay, en ons gaan later 'n hoofstuk daaroor doen. But for now you can see it gives away 2 hydrogens, so it's going to react faster. It has more to give. Okay, that's the first one. Then the second one is the surface area, die oppervlakte area. The surface area, die oppervlakte area. I'm going to read it and then explain. It says, wanneer 'n vaste stof verfyn word. Okay, so you take a solid and you, wat is dit in Engels? Daai. Dan neem die blootgestelde oppervlakte area toe. The exposed surface area increases. Okay, this is where in the video you said don't travel in a pack, split up. Nee? Then, now, this block here, sorry I didn't say, it's not a definition. It's not a definition. This is what you're going to write down when you answer a question. This is what they look for. Okay, so hierdie is nie 'n definisie nie, hierdie is jou antwoord wat jy gaan neerskryf. Okay, so julle gaan vir jou sê, jy het byvoorbeeld, en ons gaan nou 'n prakties doen, jy het byvoorbeeld zinc metaal, zinc granules, and you have zinc powder. Which one reacts faster? The powder. And then they're going to ask you to explain, then you're going to say, when it is then the exposed surface area is increased, and then you're going to say, and this is where you get your marks. You're going to say, thus, more effective collisions per unit time. More effective collisions per unit time, and thus the rate of the reaction increases. Okay. Baie belangrik. Jy kan nie sê daarom meer botsings nie. Okay? We just saw that it doesn't matter if you collide, if you don't have the correct orientation and sufficient kinetic energy, dan kan jy maar bots sodat jy blou word, niks gaan gebeur nie. Okay? So you must say more effective collisions. Okay? And then they can ask, what does effective collisions mean? Then you must say the kinetic energy is greater or equal to the activation energy. Or you can say sufficient kinetic energy, genoegsame kinetische energie. And the second thing, it must have the correct orientation. Die regte oriëntasie. That is what sufficient, effective collisions mean.
Juffrou, maar as jy 'n antwoord skryf, moet jy altyd sinnetjies skryf om die volle punt te kry. Of skryf jy net
Ag, jy sal sien maar 3 punte tel, so dan moet jy skryf alles nie. Okay? Then please do not forget per unit time, per eenheidstyd. Per eenheidstyd, that part is important to write down. Because it's like you guys, some of you, yes, you will pass science if you have 5 days to complete the question paper. Okay? But it can't be unfair. Some people can't have 3 hours and other people's people 5 days. Nee? So per eenheidstyd, per unit time, so that you have the correct time per day. Goeders. Okay. Goed. So sê, wanneer twee reaktante reageer om 'n nuwe produk te vorm, moet bestaande bindings gebreek word. The bonds must be broken to form new bonds. 6. Die aard van die reaktante sal die reaksietempo beïnvloed. So there. Ek het hierdie het ek op verkeerde plek gesit. Sorry. That must be there. Sorry, I did change the notes a bit from last year. Okay? The art, the nature will influence it. Those that have strong bonds and complex molecules gaan stadiger reaksietempos hê. Okay? And these complex molecules is like in organic chemistry and organiese chemie, daai wat klomp takke het, those have a lot of side chains. We said it will burn slower, the fuel, blah 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 blah. The rate of reaction will be slower. Okay. Goed, dan die volgende ene is die konsentrasie. Nee, wag gou. Nee. Ek gaan eers daar pause. We're going to take a 15-minute break.